All right, and welcome to the final hour of the QFM rain check. If you've joined us before, then you know what you're in for, but if you're new to the stream, we're excited to welcome you and explain a little bit about it. So we're doing this in lieu of being in Orlando at the IIAR convention, which was closed late last week due to coronavirus. So instead of being in beautiful, sunny Orlando, Florida, we are in Fort Wayne, Indiana, where it is 33 degrees outside. We put this together pretty quickly, but we have a live demonstration of the QFM. And with that, if you create or you log into Twitch, you can send some commands to, we have a special device that'll move the pallet back and forth. And when that happens, you can see all of the data and the QFM react to the pallet being moved around. And we'll show that really quick here. If someone in the chat is to write in pull, as in pull a pallet, just the word pull, if they write that into the chat, the pallet mover will receive the command and it'll pull the pallet away from the QFM. So let's see if that works. All right.
Here's something.
Yep. Thank you, whoever wrote that in there. Appreciate that. Okay. And you'll see the LED light change to green, which means that it is at the ready state. So when someone now types in either good or bad, so let's see if someone in the chat watching this can write good, then you'll see the pallet move up to the unit, and when the pallet is in range of the sensor, it'll turn the QFM on and it'll begin its cycle. You can see that it's pushed up tight against the QFM on this camera angle, and it'll turn on and perform a seal test, and the green blinking light will turn to blue once it's recognized that it has a good seal, which it has already. And then if you want to pull it away again. So in addition to the remote control being available on the QFM during our stream and when we're taking breaks, we have a couple of things that we'd like to show you about the QFM and teach you about the QFM. But before we get started, we have a word from our sponsors. So we're going to take you to commercial real quick, but we'll be right back.
And now, a word from our sponsor, Freeze-O-Matic. Are you tired of having your product freeze quickly and properly? Don't you just hate it when your customers are happy with the performance of your freezer? Well, today is your lucky day. The Freeze-O-Matic Blast Freezer will make sure you take days to freeze a simple pallet of product and never maximize your warehouse's profitability. Why use modern equipment like Quick Freeze, which can freeze your product in a fraction of the time, when you can use your grandfather's freezing equipment from 1960? With the Freeze-O-Matic not knowing at all if your product is frozen or not. When you make a choice, let it be the wrong choice. Freeze-O-Matic. This commercial was paid for by the Committee to Hold Back Your Freezer's Success.
Okay, thank you for our sponsors, the Freeze-O-Matic. Now, I'd like Dan, if you could give us just a kind of an overview of what we're seeing here.
Sure. At least this one camera angle has a pretty good view of the side of the unit. And if you look at this is a standalone pallet freezing system. It consists of a telescoping member, so this portion telescopes to be able to accommodate a whole range of rack opening heights. And this sheet metal area is called the reduced pressure plenum. And on the back side is a direct drive axial fan. So when the pallet approaches the unit, the controls sense that it's occupied, the fan will start, and that reduces the pressure in the plenum. And when the pallet is pressed up against there, the only pathway for the air into the plenum is through the spacer area of the pallet. So we get great velocity through the pallet area. And then just the rest of the unit, notice it's hard fastened to the structural steel beam above and below. And then the front part of the unit is hard coat anodized aluminum, and the base is it's a 304 grade stainless formed member, very heavy duty, used for pallet engagement. So it's a very robust unit. You can tell it's very straightforward to install, power, and then on the inside is a control panel, and it's really best if you kind of go through the control capabilities of the unit.
Yeah, so it's not everyone that has, we have this set up in our conference room downstairs. It's not everyone that has 3-phase 480 volt piped into their conference room. We might be the only one around that
Probably
that has that. But that's the only power that's required for the QFM. So that goes into the fan, which is an EC, electrically commutated motor, and from the motor we power the controls. And with the controls we are constantly sensing the position of the pallet that's in front of it so that we can turn it on and turn it off automatically when the pallet's put in and put away. And we're measuring the temperature, the pressure inside the plenum so that we can do a good seal check. And we're also communicating quite a bit of data off of the fan itself. We have Modbus communication with the fan, and we're collecting all of that data, and through Wi-Fi we're sending it up to the cloud. So it's excuse me, it's got quite a bit of pieces of data that it's storing and maintaining and keeping the cycle count active and all of that. So it's a fairly robust control setup.
very nice.
And now to explain a little bit more on what all you need and how a QFM can fit in your facility, we're going to switch things over to Mike Tippmann. So take it away.
Hi, this is Mike Tippmann, sales engineer here at Tippmann Engineering, and I just want to go through a few different things, kind of what the process is in our position in helping you set up your facility and planning for QFMs. First of all, as I said, the design allows for several different pallet heights and does that through telescoping design, as well as the swing seal that has a built-in 20 inches of flexibility on the pallet height. So first thing we do is look at your racking. We can go into existing racking, provided it's a structural rack or a drive-in. We can use an adapter for drive-in racking. The units are very simple to install. It takes as little as 10 minutes. We just need to make sure that the racking is set up for the units. So what we want to do is set the rack elevations so that the beams are spaced so that the beam height is approximately 6 to 8 inches over your desired product height. And the units are installed. The base plate goes down first, attached to the lower beam. Then the unit's telescoped up and attached to the top beam. Here's some specifications on the unit. They're 274 pounds, so typically structural racking is rated at 2,500 or 3,000 pounds per position, so that's not an issue with the way the unit. And then the units have the EC motor, which those are again daisy chained between each other. So you'd start out with an outlet, and then the units plug one into the next, up to 20 units on a 25 amp circuit. This is a detail sheet kind of showing the different views of the units. As you can see down in the lower corner here, this is how that bottom beam attaches. The unit actually sits down on it, has a spring-loaded keeper. Then the top beam, the unit is extended up, pushed up to that top beam, and then those back attachment clamps are actually drawn up and seated at the back of the top beam, securing that in place so the pallets can be pushed up into the position there. Electrically, the units require 483 phase, and they're under an amp per unit, and again, daisy chain one to the next, up to 20 units on a 25 amp circuit, which makes it easy to service these as well as install. This is a overall electrical layout, kind of showing what the larger system install would look like. Set an electrical panel at the end of the racking, and then outlets for every 20 units, and then they're daisy chained between the units. Racking requirements, again, need to have either structural or drive-in racking, and we'll work closely with your team to see if the existing racking that you have is a good fit. If not, we can work with you to get the right racking in there. This is another sheet. We have a lot of reference material for your team to make sure that racking is set up the way that it needs to be for these units. This is a good side view showing the QFM taking up the back pallet position of a 2-deep system. Then the product is placed in the front pallet position of that racking. This is a overview, and this happens to be a drive-in layout where the units are put in that back pallet position, product is put in the front, and then the rest of the lanes are open for product storage. As far as project types, we do both new construction and installs into existing racking, as well as in some cases where we find roll form or racking that's not set up for these units, then we'll work with you to get the right racking in there. We also work with integrating into different setups such as ASRS, and looking into the future on anything else that people are putting out there. We are working on adapting and finding ways to fit this solution into your overall warehousing system. The other thing that we want to touch on is Wi-Fi. Because we are communicating data from the units, we do need to have good Wi-Fi in place, and that's another thing that we go through when we're doing site evaluations and working with your team on making sure everything's set up for these units. And with that, I will wrap this up and we'll send it over to Bob and Matt.
And now Tippmann Engineering presents the fake news.
Thank you, Bob. Here's the updated list of closings, cancellations due to the outbreak of COVID-19. The NBA, the NCAA, PGA, NHL, all of soccer, NASCAR, MLB, and the Boston Marathon finishes out the list of sporting event cancellations. Now for sporting events, XFL and WWE Raw. Parks that are closed: Disney World, Disneyland, SeaWorld, Universal Studios, Cedar Point, Kings Island. Entertainment cancellations: South by Southwest, all music concerts, Broadway shows, and rounded out the St. Patty's Day Parade. Now back to you, Bob.
Experts are predicting hospitals to be overrun with coronavirus victims in the next few weeks. And again, in 2021, experts expect hospitals to be overrun with corona babies. And now for something completely different.
Okay, so we're going to jump into kind of the nuts and bolts of how we look at a freezing project. So when we're contacted, we generally get a questionnaire out, and we really need to know just a handful of details for us to turn around some meaningful information back from us. So the first thing we do, we send this questionnaire out, and we need to know whether it's a freezing, cooling, or tempering project. This example we're going to run through is freezing. The product happens to be chicken. And the next critical item is we need to know the daily anticipated throughput. In this example, we're going to model a 1 million pound per day throughput. Next thing we're going to do is input our expected incoming product temperature. In this example, it's 38 degrees. That's a pretty common inbound fresh product temperature. The next entry, next piece of information, we're looking for anticipated room temp. In this example, we're going to run at -10 Fahrenheit. The next thing we look at is the clear height of the room, and that's really for system modeling and projection. Next thing is our target temp for the product. Most freezing projects require a 0 degree product target temperature, so that's what we're going to run with in this example. And then we look at cycle time, the intended cycle time. In this example, we're running with 24 hours. So this customer wants to be able to turn every freezing location within 24. And then we look at how many operating days and hours that can have an effect on how many positions we recommend. And then the last bit of information above the red line is the anticipated height of the product with spacers. So we include the pallet, the product, and the spacers. In this example, we're running a range of 63 to 70 inches on pallet height. Next, we input or get information from the producer on average pallet weight. In this example, it's 1,580 pounds per pallet. So we'll then use this information to input into our heat load calculator. So we have just another spreadsheet. So the first entry, we said it was chicken, but notice we have a pull down menu and we have every kind of product we've run up against. So that has lookup tables for all the thermophysical properties. So we input our chicken, then we look at the million pounds per day throughput. We input our average pallet weight. In this example again is 1,580 pounds per pallet. Our incoming product temp 38. Our target temp 0. A room temp at -10 Fahrenheit. Target time or turn time of 24 hours. Handling time, we have this example at 0.5 hours. QFM is typically just a few seconds worth of handling. And then we look at operating hours per day. So we're going to be receiving, stocking, and retrieving 24 hours a day in this operation. Then the next cell is additional turn capacity. And that's, I'm just going to put one extra truckload of product in. And that helps the operation have some flexibility if they have loads that are coming in early. We like to have a home for every pallet as soon as possible when it hits the door. So, and that number is obviously, you can adjust that to whatever is suitable for the operation. The next group are the thermophysical properties of the material we chose, the chicken. So we start with specific heat above freezing. That figure 0.8 BTUs per pound per degree. Then our latent heat of fusion for chicken is 106 BTUs per pound. And the specific heat below freezing, 0.42 BTUs per pound degree. And the expected freeze point of the product, 27. Those are all values from the lookup table after we put the chicken in as the product. All right, the next section is throughput and planning. So that's the average pallet weight. You take the million pounds divided by the average pallet weight nets, the number of inbound pallets per day, and then based on the turn time and the additional turn capacity, we are giving you a suggested requirement for 669 pallet positions. We then look at the product heat load. So we have the sensible heat above freezing at 8.8 million BTUs. Our latent heat, 106 million BTUs. Our sensible heat below freezing, 15.54 million BTUs, totaling 130,340 BTUs for the process. We then divide that by 12,000 and by 24 hours, and it nets us 453 tons. And then we have a little bit of buffer here for estimated peak product load. So this is trying to help maintain room temperature if there's a large spike in the loading of several warm loads into the same area. We want the refrigeration system to be able to respond and maintain room temperature. So a little extra capacity is suggested there. We then add all the watts from the QFM units, and then we have a combined heat load. Then we look at the net operating hours for the evaporators in the space. In this example, we ran with 22 hours. That gives you 2 hours worth of defrost per day. So this example is netting us a suggested evaporator capacity of 660 tons, and then 669 pallet positions. Now, obviously, this 660 tons, you'd have to add in other loads, envelope loads, other lighting and material handling, ingress. All of that really needs to be added to that figure. But what we're trying to do is quantify the heat load that we're kind of responsible for in the room. Now, lastly, I'm going to show you a typical freeze curve. This was recently done in a customer's facility, but this is a very typical freeze curve where we're plotting the gold line is the room temp or ambient temperature. The blue line is an internal product probe. So the products began, initial product temp here was 39.17, and notice the sensible heat above freezing comes out rather quickly. And that's pretty much this run right here. Then we get into latent, and the word latent means hidden. So we're still removing heat energy from the product, but we're not seeing a temperature drop in the product until all the freezing is completed. Then we see the sensible heat below freezing falling out rather quickly. And it's really a function of the temperature difference between the ambient and the target temperature for the product. So it's especially helpful to have lower ambient temperatures when we're trying to finish that product down to our target temperature of 0. But that's kind of how you look at the heat load, and then this is a sample freeze graph. I think it can help make sense what we're trying to do.
All right. Thank you for being with us on this broadcast. This is the last segment of the day. And what I'm going to talk about is how data flows in and around the QFM. So there's basically two different methods of keeping track of what is happening with that QFM. We can work in the cloud, or we can work with your WMS, your warehouse management software. But before I get going on those two, there's actually kind of a backup fallback method. If you don't hook the QFM to anything, then there is an SD card that is inside the QFM, and telemetry is saved to the SD card every 5 minutes. So telemetry is made up of time and whatever the sensor reading is. So we are tracking temperature, pressure, a bunch of information about the fan itself, and making sure that our amp draw is correct, that there's nothing wrong with the fan. So there's a lot of data that we monitor and store as telemetry. The QFM is set by default to post that telemetry every 5 minutes, and then the SD card can also be used to program the QFM. So it's a very manual process, but you can program it and set attributes to change the dwell time and what determines a good seal, anything like that. So this is the offline method. Once you have hooked a QFM to your Wi-Fi in your warehouse, then it essentially becomes an IoT device. IoT stands for Internet of Things. And Internet of Things is a term that you're probably familiar with. If you're not familiar with it, you will hear it from other places, but it basically means put Wi-Fi into everything. So everything from the QFM to your toaster inside your house, they want to just put Wi-Fi into anything and everything that they can. When you look at the QFM in terms of being an IoT device, then the rest of this is fairly, it follows kind of the guidelines that have been set forth by other manufacturers of IoT devices, generally accepted practices. So the way that the QFM works by default is it sends all of that telemetry data that we discussed over here on the device or on the SD card is every 5 minutes. It posts it, and it can post it to our server and to your WMS at the same time. So it does this automatically by default with no other changes needed. Every 15 minutes, it downloads attributes. So if you'd like to change anything in the settings for the QFM, it's going to go to the cloud, download those changes, bring them in every 15 minutes. When programming the QFM to talk to your warehouse management system, it works through JSON packets of information every 5 minutes. So there's a data packet that is structured in the JSON format, and it is sent to whatever endpoint you would like us to send it to every 5 minutes. You can then, using HTTP REST API, you can send instructions. You can change parameters, change attributes on the device to whatever you want. A good use case example of this is being able to scan your pallet position barcode, scan the license plate on your pallet, and then the WMS sends this call to the device, and it tells it the cycle time, or it tells it the SKU, and once you have profiled all of your SKUs, they are stored with QFM, and it knows what cycle time should be associated with which SKU. So once you have this basic setup put together to talk to your WMS, the QFM cycle time can be changed on every cycle. This enables a couple different things to work really well. The first is when freezing, you really want to minimize the amount of time that the pallet is placed in front of the QFM. So the shorter the dwell time, then it shuts off the fan right when the product hits its target temp, which is normally 0 when you're freezing. Then you're pulling that pallet out and putting a new pallet in. This enables you to handle more pallets per day, more pallets per hour, with fewer pallet positions of QFM. The second thing that is really we found to be very, very powerful is on tempering. Tempering is a very precise operation as opposed to freezing. If you leave a pallet in your freezing equipment too long, it doesn't freeze too hard or anything like that. But on tempering, you want to be able to stop the tempering process at a certain point. And it can be different on a per SKU basis or depending on what operation is going to be happening next. So if you want to stop the temperature at a certain point or in a certain number of hours you want to shut it off, you have that ability here to shut that off on a per pallet basis. So you want every pallet that's tempering to run for 32 hours and stop. You can do that with QFM, where in any other tempering system it's a very hands-on manual process where you have to watch to make sure that the pallets don't get over-tempered. QFM does a great job. When the fan shuts off to that, it essentially pauses the tempering process, and you will see the rate of change, especially in tempering. When you have reached your end goal temp and you shut off the fans,
you're going to see very, very slow change towards room temperature. It might take 65 hours to reach your target temp, and then you shut off the fan and you leave the pallet there. And your room temp, say your target temp's 32 degrees and your room temp is 38. It could take another 2 to 3 weeks for that pallet to reach the room temperature, as it essentially serves as a pause button on the pallet. It's something that we really, in our other systems, being able to temper is much faster than other tempering methods, but being able to control precisely when that tempering process is stopped or paused, you can do that now with QFM on a per pallet basis. So now that we have all of these data transfers happening through our various databases in the cloud and in your warehouse management system, there's all kinds of fun things that we can do with that data to better operate, better understand, have a better quality product. And the way that we have set that up with our existing customers is through dashboards. So a dashboard is an essential part of an ecosystem that implements IoT devices. And you can put together all kinds of different dashboards for whatever your purpose may be, whatever it is that you're trying to do, and whatever it is your role in the company might be. So a good example of one is a TV display that we did for a customer. And with that TV, they put that out on they install that TV near the tempering system that they have, and it helps their operators know what tasks need to be done. So they might have 50 positions that are empty, and another 30 that are complete and the pallet needs to be pulled away. And then finally they might not have another 120 that are running their cycle right now. Okay, so with that information, the next piece of data that the operator would need is what are the actual pallet position location codes. So you can have a list of the location codes that are sitting there empty, so on down there. Same here with the complete. So on and so forth. So this is a dashboard that can be put together very quickly. You can put it on a TV, and the information that is on there is live. It changes as these things change. So an operator, instead of, if you'll recall on tracking blast cells, they'll say, okay, blast number 1 needs to be changed out on Friday at 9 a.m. And they would track this on the whiteboard of the supervisor's office or of the warehouse dock office, what have you there. Now we can do this tracking automatically without a whiteboard on a per pallet position basis rather than on a per blast cell basis. It really gives you the tools so that your operators can very quickly see, okay, I have 50 pallets that I need to put into the system. I have 30 that need to be pulled, so another 30, so I have 80 pallet positions available right now that could be utilized. The next dashboard that we're working on is for the general manager. So the GMs, ops manager, maybe you have some superintendents that you want to have access to this information. And this is really more analysis. What kind of utilization am I getting out of my system? If I'm at 30% utilization, then maybe it's time to go talk to the business development people and see if they can add another blast account to increase my utilization. Another key metric to keep track of is downtime. So downtime can either mean the pallet location is empty or the pallet is sitting there and it's done and it hasn't been pulled. So this could be tracked as a percentage, or it could also be that there was 88 hours of downtime this week system-wide. And giving the management the kind of access to that information helps them to make better decisions and to manage their people in a much better way. finally, the the last dashboard that we're working on to really make them as standards for people in PRW type situations is this is for a single location, so we want multiple location analysis. And we want to be able to give the area supervisors, the directors, those type of people access to multiple locations and give them the same type of information. If location A has downtime of 88 hours, but location B has downtime of 22 hours, what's different there? What are they doing that's better at getting those pallets out when they're ready to be pulled? Another thing is utilization. Being able to look at your various locations and say, okay, I have, I'm almost at max capacity at location A. So looking at location B, it only has 30% utilization. I want to take some of those QFM units, put them on a truck, and move them to location A to help supplement their capacity. So it's really, trying to make best use of the best available information and the data that we're collecting and sharing with operators, managers, and management. It's really data that we didn't have ever in the past. So it's this software is available at no cost to any of our current QFM customers. It's something that is very much beta software, but the intention and the reason that it's beta software is we really want feedback from our end customer, from our users, and understand better what information is valuable to them and understand how they want to be able to interact with that information. So dashboards are a very exciting part of the QFM system, and it's information that we really don't have and didn't have available with the other quick freeze equipment. That wraps up my section on the dashboard software. Hold on just a second. Hey guys, can you come in here? I'd like to. So we put this all together in very little time, and I really appreciate everything that these guys did to put this together. I appreciate you watching our live stream. We really didn't know how this was going to go, and thank you guys. Nothing caught fire.
A little clunky now and then, but
yeah, we lost some audio, whatever. It was great. Thank you guys so much. This is the team that put that together.
Thanks for your time.
Thank you. Thanks.